First of all, I'm going to hand out multiplication charts. This is something that might be helpful. If you lose it, too bad, so sad, you're going to have to find yourself another. So you can put this in your notebook, you can put it kind of wherever you need it. So, yeah, some people like these, some people don't even want to use it. I don't really understand. Just to help us out with kind of our topic today, so. Okay, everyone get one? Okay, so if you don't understand multiplication chart, pretty straightforward. Numbers across the row, across the column. You're just going to multiply those together. So that's these are your columns going down, then your rows going across. Multiply the two numbers, so 1 and 1, that's going to make 1. You get the idea, that's how they made the whole chart. I think it went up through what, 12s, correct? 12 times 12 is 144 in that bottom corner. Okay, so the reason I give this to you is that when we're doing our topic today, you can kind of quickly look at the actual piece of paper and kind of find what numbers are factors. What I mean by that, our main topic today is factors. This is a part of our prerequisite chapter. And this little multiplication chart helps you out with that. Because if you don't know, factors are two items that are multiplied together to make a larger number, to make product. So it's two items multiplied together to form a product. And that's the number one thing that people always get wrong in vocabulary. Product means multiplication. It's the result of taking two numbers and multiplying them together. So if I was asking for factors of things, so if I gave you a number like 12, let's say, just the plain number 12. Factors are all the numbers that multiply to give you 12. So there's easy ones, right? The first one that people always say, what's the first two numbers that you know multiply to give you 12? Just easiest one possible.
6 and 2.
6 and 2, okay, there's one. That's one. Some people might not have that one. 6 and 2, I agree. That is one set. What's another set?
12 and 1.
There's the first one I was thinking of. Like, anything times 1 is the number itself. Like, that's the first one. That's the one I start with, right? These two numbers are factors. You multiply them together, it gives you that top number. 6 and 2, that was another set of factors. Right? Those multiply together. Now, why that's important, if I throw this for you. If you look at this chart, you could find the 12s out in the white, and then all you have to do is go up and across and figure out that row and column. Figure out what column it was, what row it was, and those are the two factors that made that number. That's why the multiplication chart is kind of handy. Now, if you don't like it, it's not a big deal. Some people can think of those super fast. Like multiplication charts just come to people naturally, because I know when I was in elementary school, you just had to memorize that. They just gave you flashcards. You had to memorize what two numbers multiplied to give you what. But how I always do this is kind of what you're seeing here. I always start with 1 and 12. I always put the smaller number on the left, the bigger number on the right. Start with 1, because I know 1 goes in everything. Then I would try 2 and see 2 goes into it. Well, we do know that, 2 and 6. Then I would try the next number I would try is 3. What number can you multiply by 3 that would give you 12? 3 and 4, right? And now at this point, these numbers are almost exactly the same number. There's almost nothing between them. There's only decimals, right? So I can't go any further. Like those, what you're looking at there, those are every set of factors for the number 12. How I knew how to stop is I always start with 1. I would try 2. If 2 didn't work, maybe give me a weird decimal. Because 2 times some number won't give me that. Then I would try 3. And the minute I stop is when these two numbers are either the same digit or they're so close together I can't use anything in between them because it would be a decimal. I don't want decimals for factors. They have to be whole numbers only, like natural numbers. Natural numbers, if you don't know, natural numbers are the numbers you learn in elementary days. Thinking about back into kindergarten, first grade. The first numbers you learn, right? 1, 2, 3, blah, 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 et cetera, et cetera, et cetera. You don't learn any decimals. That's not until 5th or 4th grade. You don't learn fractions until junior high. But those are the natural numbers. Notice I left off 0. 0 is a whole number. We don't use 0 because 0 times anything is 0. It doesn't start with a factor. Okay, questions on what a factor is, the concept of it. Now the hard part is, if you look at your multiplication chart, what does the row and column only go to? 12s, right? So if your number happens to be bigger than 12, this chart isn't going to help you anymore. That's the hard part. Now you got to be thinking about how to do it. There's different strategies for it, but that's the concept. I can teach you like different methods for finding factors. What you're looking at here, this is actually called a factor tree, where you start with like the smallest number possible, 1. Then you try 2, then you try 3, and just keep going until the numbers either get so close together you just stop. For some people that makes the most sense, because you just keep going until you can't do anymore. But the problem it relies on is that, do you even know how to multiply? Some people don't. I've definitely seen people like, where if I give you 2, like the number 2, you just try to add 2's until it makes that number. So it's like, okay, so 2, 4, and then 6, 8, 10, 12. So like you just had to count how many sets of 2's you added together. And that's why people use their fingers. They count how many times can I add 2, like add 6 times to make 12. But for some people that doesn't make sense. So you have to just think about, okay, can I divide them? Can I just think about numbers that multiply? Because again, this section is about not using calculators, right? That's the whole point of this first chapter. Can you learn strategies to figure out factors, how to add, subtract, multiply, and divide in your head really fast? Because that's what most people struggle with in math. It's not actually like the weird, complicated stuff. It's just like the simple rules that you're like, oh my God, that was a rule? No one ever taught me that rule. And so this is one strategy. But again, it requires you how to multiply, so it's not really the best. Now there's, again, that's called a factor tree. That's one method. Second method is the one that I actually like the most. I know this seems a little weird. It's just because I can break down numbers really quickly, and I never have to think about like the options, or I wouldn't have to technically use a multiplication chart. So, for instance, let's say I went with a number, I don't know, let's go with like, with 28. Oh, kind of a weird number. Okay, so now this method is different. I'm not going to start with 1, I'm not going to do that. What I'm going to think about is, this method is called prime factorization. That's the method I'm going to use. I have other names I use it. I've definitely seen it referred to as hockey stick. I've seen it referred to as a tube sock. Just because that's what it appears to look like. This method, to me, is the fastest way of doing something. It's the fastest way of finding factors of something, but it's not, I would say it's not as clean as that. It's just, this is definitely an easier strategy, if that makes sense to you. So here's how you do it. What you do is you have to use what they call the prime numbers. So it's different than that one. That one starts with 1, you try 2, you try 3, you try 4, and you just keep going down the list. But this one, you can only use prime numbers. Now, what prime numbers are, these are numbers that you cannot break down any further. There's a set group of numbers in this world that you can't factor them apart. They don't break up at all, right? So the first prime number that we always use is the number 2. It can't be broken down. There's only 2 numbers go in the number 2. It's 1 and 2. Nothing else goes into it. Then there's 3, 5, 7, 8, 9 doesn't work, 10 doesn't work, 11 does, 13, 17, 19, 23, and et cetera, et cetera, et cetera. Like these numbers, these are just the first, 5 or 6, right? These numbers I can't break down into other than 1 and the number itself. Like 17, just 1 17. There's nothing else that goes into these. Now, where I got this list from, this is just a list I've memorized. These numbers are the only numbers I use in this. I always start with 2 until I can't use 2 any further. Then I would try 3. I would try 3 until I can't use it further. Then I try 5. Then I try 7. But again, why I think this is the easiest strategy is because you already know numbers you have to try to use. It's not like that one where it's a free-for-all. you have to start with 2 on this list, then you try 3, then you try 5, then you try 7, and you see if you can break down this number into like these weird separate branches until it can't go any further. Okay, so does everyone understand the numbers I'm going to use here? Okay, now this requires you can divide a little bit or just think about common sense. Okay, all right, so when I look at this first number, this is 28. In 28, does 2 go into 28? Yeah, here's how I know 2 goes into it. It ends in an even number. Evens are 0s, 2, 4, 6, or 8. It ends in an 8, so 2 will go into it. So here's how you break this down. We know 2 will go into this. This is the first number I'm checking. I need to check if 2 will go in. So what you do is you take 28 and you split it in half, right? So what's half of 28?
14.
Okay, boom. Now, here's the best part about doing this strategy. That's one set of factors, okay? We'll come back to that later. But you don't have to think about other ones. I don't have to do this where I have to like think and like look at my little chart and try every combination known to man. This is the beauty of doing this one, is now that you've done 2 and 28, 2 and 14, now what you do is you try to break down this number further, the one on the right side. Because on the left side, I only write these numbers down. So again, we would start with the 2 over again. So does 2 go into 14? Yeah, it does, right? Because it ends in an even number, so 2 goes into it. So what's half of 14? 7. Okay? So we get to that point. Then because again, I'm just using primes, and when I get here, I try to break this down even further. Well, is that number the number that ended with in this list?
Yep.
Yeah, it's right here, you're done. Now, the cool part about doing this, it took no mental effort to do it, other than just, can I split things in halves? Or if you had 3s, can I split it up in like triples, like 3 numbers? But here's how this works. The numbers that you circle, so this is where it comes to with like a tube sock or a hockey stick. You just circle the numbers on the left side until the last number, where the last number should be in your list of primes. This. Now, why I circle those? Those numbers alone, just those numbers, make 28, and they make every factor 28. So using these 3 numbers and the number 1, I can make this entire list without having to think about it now. I can make every combination of factor known to man, just for the number 28, by using a 2, 2, and a 7, and a 1. So now I can, just using these 3 numbers, a 2, a 2, and a 7, I can make that tree without looking at my little chart anymore. So I know that it's 28 is the first, so I'm going to do this old factor tree. We know that 1 and 28 go into it, right, because 1 goes into everything. Then I know 2 will go into it, and we already said it was what, 2 and 14? 2 and 14 went into it, because we already knew that. 2 went into it, that was the first list we already had. Then the next number I try is 3. Well, is 3 in this list? No, so I don't try 3. Then I would try the next number. I would try 5. Is 5 in this list? No. I would try 7. Well, 7 was in the list. 7 was in this list. And what you do is, the other factors, if I use 7, you just use these 2 numbers, the 2 that are left over other than 7, and multiply those together. What's 2 times 2?
4.
4. You're done. There's the whole factor tree for 28. You just use the numbers that I've circled to make every combination known to man. And if there was other numbers, maybe there was more numbers than just these, you'd keep going and you try to use every combination of like the numbers on the left side here, and you make every combination known to man. Other. It's one of those things like, why I would ever do this? I think it's the fastest method because I can break down numbers really quick, and then I can go back and make this factor tree. Now, some people are really good at this. Like they can use this thing, and it's like they just know instantly. They can find all the 28s up here and find every combination. I mean, the problem is, what is it? 2 and 14? I don't think is even on this list, is it? For 28, maybe it is. 2 and 14. No, because it doesn't go to 14. So that's where that list would fail. That's why this would be the easiest way to do it. I'd probably say that most people, if you're even somewhat familiar with factors, like you'll just try those. Try 1, try 2, try 3, try 4. If you, especially if you're at home and you have a calculator, that's what I'd be doing without writing any decimals down. But here's my question. Do we feel comfortable with what factors are? Do we understand the concept like two numbers multiplying? Okay. All right. So this is like one of our first things we're doing in this first unit, right? We're trying to think of like what are all the different numbers that can multiply together to give me the top. Now, the second type of problem that I want you to know is what they call a greatest common factor. So if you were not just looking at one set of numbers, but you're looking at two, right? So you're comparing two different numbers and you're trying to find the greatest number that they have in common, right? The greatest number that they have in common. So for instance, let me get rid of this prime thing. I'll leave these on the board. Actually, I'll just leave those two. All right. So if I was comparing two different numbers together, let's say, instead of just looking at one number and breaking it down, but if I was comparing, and they call this the GCF, or greatest common factor, right? It's the number that when you look at both lists, what's the biggest number they have in both lists? So if I was looking at 12 and 28, and you look at this list over here, these 6 numbers over here, and these 6 numbers, which number is the biggest number they have in common? 28. Does 12 have 28 in that list? No, so I can't pick 28, right? What is it? 4. Boom, there's your answer. This number, that's the GCF. That's when you look at that list, you look at that list over there, the biggest number they have in common is 4. They both have 4s in there. They both have 2s, they both have 1s, but 4 is the biggest number they have in common. That's a GCF. Now, why do you ever want to do this? Like, because most people go, okay, why do you ever do greatest common factors? Like, what's the whole point of doing that? It's when you want to simplify a fraction. This is something that a lot of people don't get when they're in Algebra 1, or they don't get in junior high when they're doing like pre-algebra or those weird other classes you have, 6th grade math or whatever. When they're given fractions, it's like the number one thing people fear when you're in like junior high, right? You get a fraction like 12 over 28, and your teacher, your instructor goes, okay, simplify that down. And then everyone has like a panic attack, because they're like, oh my God, I hate fractions. Because you're never taught like the best way to do it. The best way to break down 12 over 28 is to look for this number. To find the biggest number they have in common. That's all you do. You just break down the list of 12, break down the list of 28, find the one number they have in common, and get rid of it. So, do you agree that the 28 and 12 both had 4s in common, right? If I got rid of the 4, what's the number right next to the 4? So on the 12, what was the number next to 4?
3.
What was the number next to the 4 over here for 28?
7.
There's your answer. You just get rid of it. Yeah, but they never teach you that. They never teach you like why you ever do stuff or why it even connects ever. It always boggles my mind. Like they're teaching all these kids like these weird strategies and these dumb ways to do things, but they never just sit back and go, okay, what's the easiest way to do it? It's this. This is why they do it. But again, it does take effort, right? To actually break down a fraction, you do have to do those two lists, right? Now, don't have to do 28 the way that I did it earlier, doing the stupid sock method or whatever you think of it. But this is one strategy. Even if you didn't think of the number 4, you could have tried 2, get rid of the 2s, and then you could have went further after that. So, there's different strategies and why they do it. But I thought this is just something like people just don't think of that. Or you're never taught that, which is kind of a shame. All right, let's try one more. And then I want to go to that worksheet we did yesterday. Talk about that. Okay, because I think kind of beat this one down. But let's try some different numbers here. Let's try something maybe a little bit bigger. Find a number that's on your chart there. I don't really care what number. Just find a number, throw it out there. Say it? 88. 88. Let's do this. All right. Okay, so we're just going to do 88. 88 is big, so I'm expecting the tree to go on for a while. I'm going to do this 2 different ways. I'm going to do it by the first method, that little tree method, and then I'm going to go over here and do that like sock method. So I'll do it 2 different ways, and you'll see that they should be the same answer. All right. Okay, so what's the first number I always check for when I do the little factor tree?
2.
1. I always try. If I do the sock method, I would try 2. We'll get to that here now. I'll do that method here in a second. So I tried 1. Now, this is the factor tree method. So this is the factor tree. Okay, so now the next number I try, I'm going to try 2. That's the next number I'm going to try. Does 2 go into 88? Yeah, it should because duh, it ends in an 8, so 2 should go into it. So what's half of 88?
44.
44. Okay, so we're getting smaller. Now, are these numbers exactly the same digit? Or are they super close together? No, they're like way apart. So I'm betting on there's probably more numbers going down. Okay, that's what I'm betting. So now I'm going to try 3. So if 3 works. Now, what most people do, if I wrote 3 up here, you'd sit there and go, okay, does 3 go into it? You sit there and spin the wheels a little bit. Well, some people forget the strategy. For 3, I don't know if you've ever taught this, what you do to figure out if 3 goes into 88, add 8 and 8 together. What do you get? 16. Does 3 go into 16?
Yeah. No.
Does 3 goes into 15, not 16, so 3 doesn't work. A lot of people don't know that strategy. Like I remember learning that in my 8th grade. Right? Does 3 go into something? I add the two numbers together. If 3 goes into that number, then 3 works. But 3 doesn't work. 3 doesn't go into 16, it goes into 15. So no good. Nope. No good on that. So I'm going to try 4 now. 4, yeah, 4 should go into 88. Reason why? 4 goes into 8 and 8. So just think about that. So if I divided 8 by 4, what would I get? 2, and divide 8 by 4, I get 2. So it's 22. You just divide both by 4s individually. So now, is 4 and 22 close together? They're getting there. They're not like right side by side in the number line. There's still some numbers in between them. So I'll move on. Let's try 5. Let's try 5. So, because I've already done 4, let's do 5. So for 5 to work, this number 88 has to end in a 0 and a 5. Does this end in a 0 and a 5? No, so 5 doesn't work. Like it's the easiest thing in the world to check for 5s. Ends in a 5 or a 0. Doesn't work. Let's try 6. So for 6 to work, 2 and 3 have to work. Does 2 work on the number 88?
Yeah.
Did 3 work?
No.
No, so 6 doesn't. I'll write all these lists down by the way. I'll have you this entire list by you. Is that Eric? Perfect. How'd that go for you? Okay.
Pretty good.
Yeah. I just want to see what you know, right? All right. So we tried 6. Yeah, 6 didn't work. We tried 7. 7 doesn't really go into anything. So I can tell you right now, I'm not even going to attempt 7. So I'm going to try 8. Well, 8 probably should go into 88. Just saying. How many times? If you divide 8 by 8, you get 1. Divide 8 by 8, you get 1. It's 11. Just divide each by 8. So it's 1 and a 1. So it's 11. Now those are getting closer together. Now we're into business here. Right? 8 and 11 are nearly the same number. What are the numbers in between? We have 9 and we have 10. 10 won't go into 88 because for 10 to go into something, it has to end in a 0. And for 9, it's the same rule as 3. Add these together, that makes what, 16? Does 9 go into 16?
No.
No. So there you go. There's your entire list. Now again, that's a strategy you probably have never been taught before, how to just break down numbers like that. Maybe you have, good for you, but it's one of those things like, it'd be nicer if you had a calculator, right? You could divide by 1, divide by 2, divide by 4, 3, 4, 5, and you just keep going until you don't get any decimals. But again, where do I stop is when these numbers are nearly identical, and they're nearly the same number. But guess what? I'm only counting up here, and I'm trying to stay as close as possible. So the next number I try is 9, then 10, and I already got 11, because 11 already has them. That's how I know, is count up. Now, for some people, that was a nightmare. Like you look and go, oh my God, I'll never be able to do that. Some people do that, like you can't think that way. That's fine. So the other strategy we have for 88 is we have that little prime factorization, the sock method, the hockey stick. So this is the one that I think we even said earlier. You always try 2, then you try 3, then you try 5, 7, 11, 13, then you try 17, 19, blah, 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 blah. These are the numbers we're trying, right? So, we tried 2. Did 2 go into 88? Yes, it did. right? 2 went in there, what, 44 times? Can I break down 44 even further? Yeah. What order do we try first? Try 2. 2 go into 44, 22 times, doesn't it? I take 20, or 44 and split in half. Does 2 go into 22 again?
Yep.
Yes, it does. 2 and what, 11? And I'm done there because 11's on my list. I can't break down 11 any further. So I circle these numbers together. These 4 numbers are going to make that stupid list over there. So, how I know that? 1 goes into everything, so 1 goes into everything, 188. 2 went into it, well we already did 2, what, 2 and 44? Now, I've already done 2, so the next number I would try is I would multiply these together. So I get 4, right? If I multiply these 2, because I have 2 2s here, so I multiply together, that's 4. And then, since I did these 2 multiply together, you just multiply these 2 together. So what's 2 times 11? 22? 4 and 22. Then the next number I would try is I would multiply these 3 numbers together. What's 2 times 2 times 2? 8. And what's the last number that was left over? 11. The whole list. Without ever having to think about it. You just use the 4 numbers you're given, and you just try different combinations of multiplying everything together, and it makes the entire factor tree without having to think about all those weird strategies. Some people like that. I think it's easy. But again, it comes down to whatever numbers you have, those 4, you have to like make every combination possible. But it does make the entire factor tree. So, questions at all about factors or prime factors? Now again, do I expect it to be perfect? This is like a first day. I'm really throwing you in the deep end the first day. Okay. Do we feel maybe a little bit better about the word? Maybe not perfect, but you feel at least you know what we're doing. Okay, let's go through our little worksheet here today. Okay, this is the thing I handed out yesterday. Did you just give yours to Miss Bumper?
No, I haven't.
Oh, for I'll take it. So. Okay, I'm gonna hand these out. Eric, I won't have yours. You probably already know what you're doing first. That's not a big deal. So. Boom. Mason. And
What?
Dark. Okay. Okay. Let me get rid of this. All right. Let's go through the answer key, just so you kind of know what it's out of. It's out of 42. Don't like go, oh my God, what have I done? It was the first day. I want to know like what you know as of that moment, because maybe you're super proficient at Algebra 1. Like, it was just one of those things like on Saturday's test day, you just didn't have a good day. So I want to see maybe you're in the wrong class. So the average, I think, in total was, it was over 25. So if you didn't score up 25 or higher, you probably want to move to another unit on different sections. So that's kind of what we were looking for. All right, so let me pop up the actual quiz here.